Pre-statistics. Introduction to quadratic functions. Lesson objectives. Define parts of a polynomial function. Recognize typical graphs of the quadratic and cubic functions. A bouncing tennis ball has a graph that is quadratic in nature. It is symmetric about what is known as the axis of symmetry, and there are many real-life situations that have this pattern. Let's look at a few. These four graphs are graphs of quadratic patterns, and here we can see if we change this angle, then the shape of the quadratic changes also. The motorcycle jump is following a quadratic pattern. It's going up and then it comes back down. Ballistics. When a bullet is shot from a gun, it doesn't travel in a straight path, but in a quadratic path. Even in sports such as basketball and football, the ball follows a quadratic pattern. Water coming out of a water hose follows a quadratic pattern. So do fountains. And if we look at a satellite dish and take a cross section of the dish, or even many lenses, it will have a cross section pattern that looks like a parabola. And the reason for that is one of the properties of a quadratic shape called a parabola is it focuses these rays all at one point. Many bridges have quadratic patterns, and of course this is the Big Mac bridge, and quadratic patterns can even be found in video games. You probably played this game before, Angry Birds. The path of the bird follows a parabola. Back to the video, lesson objective number 1.
Definitions. A term is a constant, a variable, or a product of a constant and one or more variables raised to powers. Examples: 3x to the 6 is a term, x, negative 3, x to the 1/2 power, and negative 2x to the 3rd, y to the negative 5th are all examples of a term. Terms in an expression are separated by addition and subtraction. A monomial is a term, a variable, or a product of a constant and one or more variables raised to counting number powers. Sometimes this is known as natural numbers. Let's look at some examples. This is a monomial, 3x to the 6. 6 is a counting power. X is a monomial because it has a power of 1. Negative 3 is because it has a power of 0. So x to the 0 power is 1, and 1 times negative 3 is negative 3. And the last example, negative 5, x to the 7th, y to the 4th, is a monomial. The powers are counting numbers. A non-example would be x to the 1/2 power. That is not a monomial. Another example would be x to the negative 3 power. Negative 3 is not a counting number, it is not a natural number. A polynomial or polynomial expression is a monomial or a sum of monomials. Example: so this is a polynomial that has 4 terms. The terms are separated by addition or subtraction. This is a 2-term polynomial. So is this a 2-term polynomial. 5 is a polynomial because it's a monomial. So is x, and so is negative 2x to the 3rd. We write polynomials in descending order. So to put a polynomial in descending order, we need to talk about what's called a degree. The degree of a polynomial in one variable is the exponent of the variable. Negative 7x to the 4th has a degree of 4 because that is the exponent for the x term. 2x to the 3rd, y to the 5th has a degree of 8 because this is one term and we add the exponents. So 3 plus 5 is 8. The degree of the polynomial is the highest degree of any non-zero term of the polynomial. So for this polynomial that has 3 terms, this has a degree of 5, this has a degree of 3, this one has a degree of 0. We take the highest, so this polynomial has degree 5. Example 1. Use the words such as linear, quadratic, cubic, polynomial, degree, 1 variable, and 2 variables to describe the expression. Number 1, we have negative 3x squared plus 8x minus 4. Number 2, we have 5x to the third minus 2x squared plus 9x plus 1. And number 3, we have 6a to the fifth b squared minus 9a to the third b to the third minus 2ab to the fourth. Solution. Number 1, the term negative 3x squared has degree 2. It's the highest degree. Now notice this is in descending order also. Degree 2, degree 1, degree 0. Because this is the largest degree, we say this is a second degree polynomial. And this is known as what we call a quadratic. Number 2, polynomial has 4 terms. So we have degree 3, degree 2, degree 1, degree 0. This is what's known as a cubic. Number 3, so this polynomial has 3 terms. The term 6a to the fifth b squared has a degree 7. It is the largest, so we say this polynomial has degree 7. So we would call this polynomial 7th degree polynomial. Lesson objective: recognize the typical graphs of quadratic and cubic functions. Names of polynomials. There are different ways to name polynomials. If we name the polynomial by the number of terms, a monomial is a 1-term polynomial. Binomial is a polynomial with 2 terms. Trinomial is a polynomial with 3 terms. And if it has more than 3 terms, we just call it a polynomial. If we go by degree, 0 degree is a constant. 1st degree polynomial is a linear. 2nd degree is a quadratic. And the 3rd degree is a cubic. Quadratic functions. Definition. A polynomial function is a function whose equation can be put in the form f of x equals p, where p is a polynomial in terms of the variable x. If p is a quadratic 2nd degree polynomial, we call the function a quadratic function. A quadratic function is a function whose equation can be put in the form f of x equals ax squared plus bx plus c, where a is not equal to 0, called the standard form. A cannot be equal to 0 because this would disappear and we would be left with a linear function. A, b, and c are coefficients. For f of x equals negative 2x squared plus 5x minus 1, find the following. Number 1, f of 4. Number 2, f of negative 3. And number 3, f of 0. Solution. F of 4 simply means we take this polynomial expression and everywhere we see an x, we substitute 4. Next, we follow the order of operation. We have to square before we multiply. So 4 times 4 is 16. We have to multiply before we add or subtract. So this would be negative 32 plus 20 minus 1, which gives us an output of negative 13. So when x is 4, the y value will be negative 13. Number 2, f of negative 3 becomes negative 34. And the last one, f of 0, becomes negative 1. Now this is also known as the y-intercept. So if we were to graph this quadratic function, the y-intercept would be negative 1. We can use the graphing calculator to compute these values for our quadratic function. Our first step is to put the equation in our y equals. Next, we want to go back to the home screen. Then we want to press vars button, which is short for variable. Go to y vars, number 1, which is function. We put the equation in y1, so we want the function y1. And then we put parentheses the value that we are interested in. So when x is 4, y is negative 13. When x is negative 3, y is a negative 34. And when x is 0, y is equal to negative 1. Sketch the graph f of x equals x squared. This is a quadratic function, so we can make a table of values. It's good to pick some negative numbers, 0, and some positive numbers. Negative 3 squared becomes positive 9 because negative times negative is positive. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Using graph paper, we can plot these xy coordinates, and this is what the graph of a quadratic function looks like. We call this a parabola. Using the graphing calculator, we type in x squared into y equals and hit graph, and we have our parabola. Definitions. The graph of a quadratic function is called a parabola. The lowest point on a parabola that opens upward is called the minimum point. The highest point of a parabola that opens downward is called the maximum point. The minimum point or the maximum point of a parabola is called the vertex of the parabola. The vertical line that passes through the vertex is called the axis of symmetry. Here we have the axis of symmetry. This is the vertex. The vertex will always be on the axis of symmetry, and in this case, for this parabola, this vertex is a minimum point. For this example, the vertex is a maximum point, and again, the vertex is located on this axis of symmetry. A graph of a quadratic function f is sketched. Number 1, find f of 4. Number 2, find x when f of x equals negative 3. Number 3, when f of x equals 5. And number 4, when f of x equals 6. So for number 1, find f of 4. So this means find the y value when x is 4. So we go to the x-axis to 4, and we see that this point is 4, 3. So when x is 4, y is 3. So the answer to number 1 is 3. Number 2. Here we're given a y, we want to find the x. So this time we go to the y, we look for negative 3 on the y, which is here, and we see that there's 2 points on the parabola when x equals a negative 2 and when x equals a positive 6. So this has 2 answers. Number 3, when y is 5, 1, 2, 3, 4, 5, we see that this is only one x, that x is 2. So for number 3, the answer is x equals 2. And number 4, when y is equal to 6, there is no point on the graph when y is 6. So this is undefined. There is not an answer. It's the empty set. Cubic functions. Definition. A cubic function is a function whose equation can be put in the form f of x equals ax cubed plus bx squared plus cx plus d, where a is not equal to 0. A, b, c, and d are all coefficients. Sketch the graph of f of x equals x cubed. We first want to make a table of values. It's a good idea to pick some negative numbers, 0, and some positive numbers. Negative 3 cubed is negative 3 times negative 3 times negative 3, which is a negative 27. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0, so on and so forth. Plotting these on graph paper, we see the shape of this cubic function. Here are some more typical graphs of cubic functions. Using the graphing calculator, we go to y equals, type in x raised to the third power, and hit graph, and we see the graph of the cubic in our window. To look at the table, we hit second and graph, which is table, and this is the same table that we did by hand. Thanks for watching.